Project title: Understanding PIO Control Registers with TMS320F28335 Microcontroller. Description about PIO Control Registers. In this tutorial, we will delve into the world of PIO Control Registers and discover how they can be utilized with the TMS320F28335 microcontroller. PIO control registers are special registers that provide fine-grained control over the general-purpose input/output (PIO) pins. By understanding these registers, you can configure and control the behavior of the PIO pins, enabling you to interact with external components and create innovative projects. Join us as we explore the PIO control registers in depth and demonstrate their usage with a code example. Welcome back to MeviHub.com. Today, we'll dive into the world of PIO control registers and explore how they can be used with the TMS320F28335 microcontroller. Let's get started. Before we begin, let's quickly understand what PIO control registers are and their importance in microcontroller programming. Specification: TMS320F28335 microcontrollers. On-chip memory: 256K x16 flash, 34K x 16 SARM. Clock frequency: up to 150 MHz, 6.67 ns cycle time. Operating voltage: 1.9 V/1.8 V core, 3.3 via IO design. 6-channeled microcontroller for ADC, MCBSP, EPOM, synth, and SARM. Communications peripherals: up to 2 CAN modules. Up to 3 SI, UART, modules. Up to 2 MCBSP modules, configurable as SPI. 1 SPI module. 1 inter-integrated circuit, I2C, bus. Analog subsystem: 12-bit ADC, 16 channels. 2 sample and hold. Single/simultaneous conversions. Internal or external reference. Enhanced control peripherals, up to 18 PWM outputs. Up to 6 HRPWM outputs with 150 PS MEP resolution. 16-bit or 32-bit external interface, synth PIO 0 to PIO 63 pins can be connected to one of the 8 external core interrupts. Up to 18 PWM outputs. Up to 6 HRPWM outputs with 150 PS MEP. Up to 88 individually programmable, multiplex PIO pins with input filtering. 3 32-bit CPU timers. Here the TMS320F28335 microcontroller diagram. Here the PIO pins on the microcontroller. PIO control registers are special registers provided by the microcontroller to control the behavior of the general-purpose input/output (PIO) pins. These registers allow us to configure whether a pin is an input or an output, enable or disable pull-up resistors, set pin direction, and perform other related functions. PIO control register structure. Let's take a closer look at the PIO control register structure and its components. Display the PIO control register structure and explain its key elements. STR controls pin direction, input or output. SPUD enables or disables pull-up resistors. SMUX1 configures the pin multiplexer settings. XSOL sets input qualification mode and related parameters. CACTRL manages general properties of the PIO module. These registers provide us with fine-grained control over the PIO pins, allowing us to tailor their behavior to suit our specific requirements. Code example: Now, let's dive into a code example to see how we can utilize the GPIO control registers in practice. Show a code snippet that configures a GPIO pin as an output and toggles its state. Host. In this code snippet, we initialize the necessary GPIO control registers to configure a pin as an output. We then use another register to toggle the pin state, creating a simple blinking effect. In the above example, we begin by including the appropriate device header file. Then, within the main function, we use the microcontroller structure to configure GPIO3 as an output. ELO and EDIS are macros used to enable and disable access to certain sensitive registers. microcontroller.bit.gpio3 equals 1 sets GPIO3 as an output by modifying the GPIO register. The gpio.bit.gpio3 notation selects the specific bit corresponding to GPIO3 within the GPIO register. After configuring the pin as an output, we enter a while loop to toggle the state of GPIO3 with a delay of 1000 milliseconds. cassette.bit.gpio3 equals 1 / turns off the LED. 1 means turn off, 0 means turns on. Sets GPIO high or on by modifying the cassette register. Similarly, clear.bit.gpio3 equals 1 / turns on the LED. 1 means turn on, 0 means turns off, clears GPIO3, setting it to low or off. The delay _S1 million macro is used to introduce a delay of 1000 milliseconds between state changes. Scene 4, Demonstration Host. Let's power up our TMS320F28335 microcontroller and witness the GPIO control registers in action. Show the setup with the microcontroller, breadboard, LED, and necessary connections. Run the code example and demonstrate the blinking LED effect. As you can see, by leveraging the GPIO control registers, we have complete control over the behavior of the GPIO pins. This enables us to interact with external components and create various applications. Thank you for watching, and remember to visit mibihub.com for more innovative projects and technology-related content. Stay secure and see you next time.